Hello everyone! Ako si Dr. Esperanza at kung bago kayo sa channel ko, ako yung nagtuturo ng math videos dito sa YouTube. And today, it's going to be a little bit special dahil dadalhin ko kayo kasama ng mga estudyante ko para mag-aaral ng calculus, specifically sa pagsagot ng mga problems involving limits. So kung may oras kayo, just stick around at makisit in kayo dito sa classroom ko dito sa California. And for today, we're going to dive into what limits are, why do we solve for limits, how do we solve for limits, and what exactly are limits. Because in calculus, it's extremely important that you're understanding the concept more than the steps on how to find the answer. Because if you're just going to memorize steps, like this is the step in finding a limit of a function, you factor this out, you solve for x, you substitute, and then you're done. However, you need to know why you're using that method, why you're factoring, why are you substituting the value of that function to f of x, and so on. And that's what we're going to be learning today. Where's my... So this is an example of a limit of a function. And most students, they are intimidated with the fact that they're looking at a math problem that it's too foreign for them. Because mathematics, you need to treat it as if you are learning a foreign language. And when you say foreign language, you just don't learn it by listening or being able to speak it. You also need to know how to read it, and you also need to know how to write it. And that's basically how you know that you're learning good mathematics. If you can speak it, if you can read it, and you can write it. Not just do the math and do all the multiplication and crazy factoring techniques in your paper. Because learning calculus is like learning art because it's so intricate. The math details needs to be on point for you to be able to communicate well with your work. Because if you can communicate well with your math work, it makes math a lot more exciting and it makes more sense. That's why in sciences, you need to have good foundation in mathematics to be good in physics, to be good in chemistry, to be good in biology. You need to have a strong background in mathematics to be able to understand that. Because if you can read this and understand this, then it's easy. All right. So this is a limit of a function, and you read it as limit of 2x squared minus 5x minus 3 all over x minus 3 as x approaches 3. Too much? Yes, but there is a reason why it's a little bit too much. It's because this particular symbol is actually telling you what you're supposed to be doing in a math problem. You're not just solving for x, you're not just substituting, you're doing something else. And we're going to go through that in a little while. So this is another limit of a function, so get used to seeing these functions because it may look complex and too much to work on, but it's actually really simple once you know the language. This is another function that you will encounter in calculus. Not just an absolute value, but a fraction in this sense. And we're going to be solving all of these, hopefully, today. Anyhow, so this is another function. This part right here, it's all algebra work. If you're not focusing on this crazy symbol right here, you'll think, it's so easy to solve. Maybe you're just simplifying fraction. And yes, that is basically what you're just doing here. So this one, I'll make sure that at the end of this workshop, you'll be more comfortable working with math problems that has these crazy symbols, so that when you see math problems, you don't break out on hives and think that this is a problem that is impossible to solve. So that is our goal for today. All right, now, before we dive into solving a limit using mathematics, you need to understand that function in calculus can come in any form. This one is probably the most common form of functions that you've seen from basic algebra to trigonometry to IM3 and in your other previous math classes. And this is true. This is just f of x, which is just an equation, 2x cubed plus 3x minus 1. And this f of x, or function, is in algebraic form. However, in mathematics, you're not limited to only seeing function of this form. Sometimes, you will be given a function in table form. And it's still a function. It's still f of x. So it's important that as a student, you know that f of x can come in many forms. And sometimes, it could be an equation, it could be a table, and sometimes it could be a graph. And in calculus, learning how to solve a math problem is not limited to working on math problems that is looking like this. Sometimes it will look like this, and sometimes it will look like this without any of the clues that you are used to seeing in algebra. So that's what we're going to be learning today. How to solve a limit of a function given f of x in equation form, f of x in table form, and f of x in graph form, because that's how you will learn math. All right. Notations, symbols, examples of mathematical functions that you're going to be solving, f of 2, f of negative 1, f of 0. Let's say we're using the f of x in algebraic form. I'm pretty sure that most of you, since you're in a calculus class, you'll be able to answer all of this, right? Some of you can even answer this mentally, right? So can you please solve the first one, f of 2. When we say f of 2, it means what? We're what? What are we doing if we see problems like this? We are basically what? Plugging into 2 x, yes. So 2 cubed, 3, and then you solve it like a regular algebra problem. And that is basically how you solve this problem. And you know this because you know the language, you know the symbols, and you're understanding the question easily. All right. F of 0. Is it 0? No. So this is a common error that most students do. When they see f of 0 or x equal to 0, automatically they'll say, oh, it's 0. That's not, because this turns into 0, we know that. This turns into 0, we know that, but we know f of 0 is equal to negative 1. F of negative 1, it is equal to negative 6. And if it's f of 0, it's equal to negative 1. Now, in mathematics, this notation can be converted into a point. Did you know that? Did you know that this, and this represents a point in this graph? Because this f of x can be a graph. If you use a graphing calculator, plug this into the graphing calculator, push graph, and it will show you a cubic function. Which means at x equal to 2, this is your xy plane, at x equal to 2, y value is 23. If x is equal to negative 1, y value is negative 6. And if x is equal to 0, y is negative 1, right? So this is basically all the values of y given x. So we can rewrite it like this. That is another way of seeing or interpreting these notations. And when we say notations, it's the way we write mathematical symbols. And mathematical symbols always mean something. And that's basically what you're looking for when you're asked to find all of these. Now, the f of x is in graphing form. It's no longer an equation, right? So, knowing what you know now, if I'm going to ask you to give me the value of f of negative 1, can you solve this math problem given that your function is a graph? Let's start with negative 1. I'll do the first one so that you'll have an idea of how you're supposed to solve this. If I'm asked to find f of negative 1, this is negative 1. At x equal to negative 1, what is my value of y?
0.
And that's basically how you're solving some functions. Functions given an equation, you substitute. Function given a graph, you just look at the graph and make sure that you're using the right ordered pairs. So this one is going to be negative 1, 0. Right? So what is f of negative 3?
0.
It's also 0. So this one, if I convert it into an ordered pair, it's, how am I going to write it?
Negative 3, 0.
Yes. What about f of negative 4?
Negative 4, 6.
About 6, right? Good job. So this one is what?
Negative 4, 6.
And that's basically what you're solving when you're working with, you're finding the values of y, but this time visually. F of negative 6,
0.
0. So we're clear? So that's how simple finding these problems. You're finding, what are you finding?
The Y.
The y value or just a point. Point in your f of x or graph. All right. We're going somewhere with this, I promise. All right.
Oh God.
Now, the f of x look a little bit more complex than the previous one because the previous one is probably just a cubic function. But this one is an equation, also known as an f of x. And this graph forms, do you know what type of graph this function is? Have you heard of this?
Piecewise?
Yeah.
Yeah.
Yes. This is an example of a piecewise defined function because you have multiple function in one f of x. You have a parabola going on right here, and then you have a line going on right there, and all of them collectively is just one f of x. So, since we're looking for 1, 2, and 3, and they're still simple, right? Because you can solve this easily. What is f of 0?
0.
What is f of 1?
1.
Yes. What is f of 2?
Wait, no.
This is 1, this is 2, right? This is x of 1, and this is x of 2.
6.
Oh, 6.
So which one is it? I have 3 options now, so what am I gonna do?
The closed point.
The closed point, because that is the one that is existing in mathematics. Everything has its meaning, and in this case, we know that when there's a shaded dot, that's an existing dot. The circle, not included. So this is what?
6.
And that is correct, because it's just a point. That's basically what these are. Let's go with this little foreign language looking math problems right here, and let's see if we can solve it. If we're asked to find the limit of f of x as x approaches 2, that's basically what or how we say it, right? How are you going to solve this problem knowing, hopefully, what the definition of a limit is? Okay, to give you a little bit of clue, so that we'll understand this better, according to a textbook, the limit of f of x as x approaches 2, if you're going to solve it, is basically finding a behavior on a graph of f of x for this particular value of x. And if you want to be more technical, in mathematics, the limit of a function is a fundamental concept in calculus and analysis concerning the behavior of that function near a particular input. Do you understand it now? Honestly, do you understand it now?
Yes.
Yeah.
Okay. Okay. So let's solve it then. What does that exactly mean? I'm going to show you a visual way on how to understand the limit of a function. The limit of a function, when you are seeing a graph, it only means that coming from the left and coming from the right, that particular value of y on x should approach a same value of y. I mean, at this particular value of x, it should approach the same value of y from the left and from the right. We're approximating x is equal to 2, right? Is this x equal to 2? Yes. So let's draw a line right here. That is x equal to 2. And according to the description of a limit, the limit will exist if the y value coming from the left and coming from the right will be approaching the same number. Let's inspect. Coming from the positive side, where is the function going to? What value of y?
8.
Yes. Coming from here, it's 8. Now let's inspect it on the other direction, coming from the left, which is the negative side, right? Where do you think is it going to?
4.
4. So there is a little problem right here. They're approaching a different value of y, which means the limit does not exist. Because the approximated value of y coming from the left and coming from the right is not on the same value. They're contradicting. And when they're contradicting, it will not exist. That's basically what a limit of a function means. So this and this is the reason why it does not exist. So now do you understand why sometimes limits don't exist? Not because Lindsay Lohan says it, it's because the graph is showing us that they're not meeting on the same value of y. So, given that, let's see if you can find the limit of this function. We already know that this one is d and e, right? If I'm going to find the limit of the function at x equal to 0, do you think it exists by just looking at the graph?
Yes.
Yes, because coming from this direction, it's approaching to this value of y. Coming from this direction, it's also approaching to this value of y. So what is the value of your limit then?
0.
Yes. So if a limit is existing, therefore there is a value of y that you can use for it to represent a certain limit. How about -1? Does it exist?
Yes.
Yes. And what is the value of the limit?
1.
Positive, negative?
Positive.
Yes. So it's safe to say that when you're solving a limit, it's basically just substituting the value of x to the function. And that is true. That's basically what a limit is. Substituting the value of x to the function, but making sure that it exists. And the only reason why we have this notation is because we are diving into a different level of analyzing a function. Because now you're in calculus, not just in algebra. That's why calculus is more exciting, because you're learning more facts and more skills to describe a graph. Next. This one.
6.
1, 2, 3, 4. Yes, and it's at easy, right? That's why solving a problem on a limit is easier if you're given f of x in graph form. Because all you need to do is look at the graph and know your notations. Why? Because if you give this to an algebra student, not knowing what we've talked about for the past 15 minutes or so, they're not going to be able to answer this. But we know it's really simple, right? So that's why knowledge is power. But the question is, how are you going to find and understand that knowledge? You come here in my classroom during Thursday and I'm available, then you'll be able to know it. Okay, what about this one? The limit of the function as x approaches 7.
Doesn't exist.
Hmm?
Wait.
Doesn't exist? 5? X is approaching 7, right? Right?
It's not on the graph.
Are you touching any values of the function at that line?
No.
Yeah, it does not exist in this particular piecewise defined function. Got it? So that's why, see, if you can understand how to read symbols in math, you can easily answer a limit or a calculus problem like this. Okay, look at this notation. What do you notice about the notations right now? What are you seeing?
They have a negative and a positive
There's a negative and a positive sign on the number. But in calculus, or in this type of notation, it doesn't mean the number is negative or x is negative. It means where your limit is approaching to, from the positive side or from the negative side. We call this, we have a special name for this, a limit. We call it the one-sided limit. And it's basically asking you what is the value of y as x approaches from that direction. So you don't care about both directions, you just care about one of the two directions that we have. Okay, so what's this? Do you have any directions on the first problem? No, it means it needs to be true from the left and from the right. And we know that this is what? What about if we have this problem? Limit of f of x as x approaches to from the negative side. What do you think is the value of the limit? Is it still going to be d and e?
No.
No. What do you think is the value now of our limit when we have a special symbol right here?
4.
4. Good job. Easy, right? Because this is what? This is x is equal to 2, right? And we need just the limit coming from this direction, right? So it's approaching this value of y, which is equal to. Okay, so we're clear about one-sided limit? So what about this? Is it also going to be 4? Because they look the same. Are they the same?
No.
Because this one is coming from the positive direction. So what would be your value of your limit now?
8.
Yes. And that?
0 from
0 from
the
the
positive side.
positive side. Which it doesn't matter because from the left and from the right it will still exist. Right? So far what we have learned is that a function can come in any form, 3 forms for that matter. 2, the limit of a function will only exist if coming from the left and coming from the right it's approaching the same value of y. Otherwise it's d and e. And there's also what we call as a one-sided limit, which is a special case of limit because we don't care about the other side. We're just concerned about the side that is given. Okay. See? So much learning. Are you absorbing all the things we're learning now? Because what we just did is solving a limit graphically. And if you want to know more about solving problems involving limits, just click on this button right here and it will give you more examples and more topics on how to solve limits algebraically, graphically, and analytically. Well, now you know what to do. You need to exert a little bit of effort if you really want to learn it, which is spend extra time out of your hours or free time to learn from the best. Alright, so let's answer this particular problem. Number 1, f of negative 2. This one is a simple algebra problem, right? So what is f of negative 2 right here?
3.
F of negative 2. Yes, 3. Limit of f of x as x approaches negative 1. This one, right?
Yes.
So coming from the positive side, it's approaching what value?
0.
And it's 0. This one is positive 1. X is equal to positive 1. Approaching from the positive side, so it's equal to
1.
1. And f of 3? F of 3?
5.
What is your answer at f of 3? Yes.
Oh, yeah, huh?
It's D and E because you're looking for a dot, not a limit. That's why you need to know your symbols. Because if you don't know your symbols, you might end up saying that it's something else. It's 5. If it's a limit, then it's 5. Just like this, number 5. Limit of f of x as x approaches 3. So this time, is it also D and E?
No.
What is it?
5.
Now it's 5 because coming from here, it's approaching this value of y. Coming from here, it's also approaching the same value of y. And what about f of 1?
1.
Is it this point or that point?
1.
It's 1.
The 1 point right here, because this one is a whole. So that is why you need to know your notation and you need to know your symbols to be able to answer a calculus problem. Did you get 6 out of 6? Easy. Let's move on to this one because I'm pretty sure you know how to do it graphically now. So in a graph form, you need to know when the function or a limit does not exist and when to solve a limit using a one-sided limit. And again, the symbol is important. The positive and a negative sign on a number, it doesn't mean it's a negative number. It means from which direction are you supposed to be looking at the function. Now, limit of this function as x approaches 3. So how are we going to solve problems like this if it will exist? We're not solving it yet because right now we're not seeing the graph, right? So if we're not going to be seeing a graph, how are we going to solve it using algebra or using mathematical process? Do you have any idea how to solve this limit of a function as x approaches 3? And again, ito si Dr. Esperanza and maraming salamat sa pagtutok nyo sa panonood ng pag-solve ng limit ng functions. And if you happen to like my video, please like, share, and subscribe to my channel at hit nyo na rin yung notification bell para ma-update kayo sa mga videos ko. Again, maraming salamat sa inyong support and see you again next time. It will exist. So if you plug in 0 right here, 0 right here, 0 right here, will you have a value that is defined?